because I'm sure that there is another conference that is happening in the month of April, right? उसमें मुझे आप प्लीज बुला लेना, स्पीकर बुलाना, आपकी बार गेस्ट मत बुलाना ताकि पूरा मैं अपना बता पाऊँ। गेस्ट को ना कम मिलता है टाइम बोलने का। So in that conference, I'm going to tell more about what Udmodya Foundation and what startup ecosystem is doing. But in a very short span of time, just one last point I'd like to highlight. थोड़ी अपनी तारीफ कर देता हूँ। In a very short span of time, हमारे startups का turnover 31 crores हो गया। दिल्ली यूनिवर्सिटी 8 साल में 19-year-old girl came from Maitri College and suggested an idea. Today, she is touching 2 crores as annual turnover within a span of 1 year. So that is the power of innovation. That is the power of your idea. So dream, and this is a good place to network as well. And I am openly welcoming you all. If you have an idea, we have money. Some people may be having money here. We have ideas. You can invest money as well. So you can contact your chairperson for that. Thank you so much for having me here, and it's lovely to be back to my college. I always say that this is my college. I miss Professor Poonam Verma, but I'm sure wherever she is, she will take care. She's going to continuously speak to Professor Shikha कि सब ठीक हो गया ना, आ रहे होंगे messages फोन पे। So thank you so much. Thank you.
Sir, for your insightful words. I would like to invite Professor Rishi Karan Sahai, sir, to kindly felicitate Dr. Abhishek Tandon with a memento and talk. I would now like to introduce Professor Prabhat Kumar, NIT Patna, General Chair, ICICC 2025. Dr. Prabhat Kumar is a professor in the Computer Science and Engineering Department. Also holds the honorable post of NIT Patna. The IT services, computer and IT. He was formerly the HOD, CSE Department, and coordinator of the He's a member of the NWG 13, corresponding to ITUG Study Group 13, Future Network with focus on he has covered journals and international conferences. Chair session. Global member of he possesses a PhD in computer science and his research area includes wireless data science, etc. I welcome sir to please address your
Respected friends on the stage. Our
And Dr. Poonam Verma, Madam is not here, but she has been very instrumental in all the equipment. So now, the background, my director, Professor P.K. Jain, sir, he has sent his blessings for this conference. The chairperson and our respected keynote speakers. On behalf of the organizing committee and NIT Patna, it is my pleasure to extend a warm welcome to one and every one of you this 8th International Conference on Innovative Computing and Communication. We are associated for the 6th year in continuation with University of Valladolid for this conference, and I'm happy to inform you that we are trying our best to increase the quality of this conference. We have taken care that proper selection is done based on merit for the paper selection, and the quality is maintained as informed in detail by my friend RCC. So this conference is proceeding to greater heights day by day, and I hope we will continue to do it better in the time ahead. I want to just tell you that we are living in an era where several technologies are growing in parallel. Just imagine AI, ChatGPT, as all students are using today, and at the same time, quantum computing, IoT. Now, these convergence of these technologies will change our entire world, the way we live, our day-to-day life, whether we like it or not, it's going to happen. And at this time, having a conference like this, where all innovative technologies and the communication medium together with industry, it gives us a platform in a very timely manner that our student community, research community, and faculty members can present their papers. So I hope in the coming time, we have very good keynote speakers with us and very interesting topics to be discussed. So our audience, whether offline or inline, will benefit with that. So I also want to thank the organizer or the organizers, especially Ashish and his team, Gulshan Srivastava and all other members for their continuous effort, which has led to this conference success. So I wish all the participants, the presenters, good wishes for the conference. Thank you.
Thank you so much for addressing the audience. Now I would like to request Dr. Ashish Khanna to ascend onto the stage to felicitate General Chair Professor Prabhat Kumar. Professor Ajay Jaiswal. Please, Dr. Kumar Vijay sir, can please stand on stage to felicitate General Chair. It was an honor, sir. Thank you so much. Now, Professor Poonam Verma, the pattern ICICC 2025, who is currently the principal of Shahid Sukhdev College of Business Study, has remained a pillar of strength for this institution. Unfortunately, she wasn't available today to join us due to some unavoidable circumstances. Nevertheless, she has sent her best wishes for us for today's conference. Now, I welcome Dr. Shikha Gupta, the officiating principal of ICICC. Dr. Shikha Gupta, currently the professor of computer science, has significant experience as faculty and as a software analyst in India and USA. She has published and presented more than 30 research papers in journals and international conferences. Author and editor of books, she has been invited as a reviewer and editorial board member for journals and technical committees, members for international conferences. Recently, she has been a member of Skill Enhancement Council of University of Delhi under the New Education Policy 2020. Her recent interests include bioinformatics, education technology, social network analysis, and process mining. We welcome you now.
Distinguished guest, Dr. Abhishek Pandit, guest of honor, Dr. Ravinder Singh, joint conveners, Professor Ajay Jaiswal and Professor Sameer Anand, General Chair, Dr. Prabhat Kumar, respected keynote speakers, esteemed faculty members, researchers, and students. It is a great privilege for Shahid Sukhdev College of Business Studies to host the 8th International Conference on Innovative Computing and Communication. While our principal, Professor Poonam Verma, has regretfully expressed her inability to attend in person, on her behalf, I extend my regards and a very warm welcome to the dedicated organizing team, conference partner institutes, and the participants. Ranked first by India Today consecutively for last 5 years, SSCBS has remained at the forefront of academic excellence and innovation. We have proudly hosted this conference for last 6 years, witnessing its evolution into a confluence of great minds, a space where ideas flourish. This is visible in more than 2,000 articles received and 400 accepted this year, covering AI-driven solutions in many domains, including cybersecurity, fraud detection, medical diagnosis. Over the next 2 days, I'm sure, you will touch upon transformative potential of AI. And let me remind you, generative AI is like a toddler with infinite crayons. It can create masterpieces, but sometimes it also colors outside the lines. This is the beauty of innovation, exploring the unknown, embracing both the brilliance and unexpected surprises. I'm sure that we are all looking forward to an inspiring exchange of knowledge. I urge all the participants to actively engage and build networks that transcend geography. Thank you very much and best wishes for a successful conference this year. Thank you.
Thank you so much, ma'am. Now, I would like to invite Professor Ranjan Gupta, who is the chairperson of the governing body at Shahid Sukhdev College of Business Studies and a professor at the Faculty of Law, University of Delhi. She also holds the position of provost at Ambedkar Ganguly Students' House for Women. Professor Ranjan Gupta earned an LLM and PhD from the Faculty of Law, University of Delhi, with her doctoral research focused on law relating to dishonor of checks. She is the editor of the Journal of Campus Law Center and has been serving as the grievance officer under the data privacy policy of the university since 2021. A distinguished academician and researcher, Professor Gupta has delivered lectures as a visiting faculty on subjects such as law of evidence, law of contract, and law of negotiation instruments at various institutes. She has published numerous research papers in nationally reputed journals and has been an active participant in national and international conferences. She is also a renowned author, having co-authored several widely acclaimed books, including The Dishonor of Checks, The LexisNexis, and Commentary on the Protection of Women from Domestic Violence Act 2005, the Vinod Nijavan publication. I would like to request ma'am to come on the stage and address the audience.
A very warm good morning to all of you. Respected Chief Guest Professor Sanjeev Singh, who had to leave for some urgent work in the university. Our guest of honor, Dr. Ravinder Singh. Distinguished guest, Dr. Abhishek Tandon. General Chair, Dr. Prabhat Kumar from NIT Patna. The officiating principal, Professor Shikha Gupta. Our Honorable Principal, Professor Poonam Verma, faculty members, the keynote speakers for today, Dr. Catherine and Professor Daniel, researchers and all participants present here, and those joining us virtually. I really extend my warm greetings to all of you. It is indeed an honor to address this distinguished gathering at the International Conference on Innovative Computing and Communication 2025. As the chairperson of the college, I am proud to witness this prestigious event taking place at our institution, bringing together some of the brightest minds in the field of computing and communication. In today's time, computing and communication is the backbone of modern advancements. Conferences like ICICC 2025 plays a crucial role in bridging the gap between the research and the real world applications. On one hand, such conferences promote collaboration, while on the other hand, they help in igniting new ideas. In the present area, artificial intelligence, data science, cybersecurity, cloud computing, and the Internet of Things are playing a big role in transforming the globe. The discussions, presentations, the research shared at this conference will undoubtedly contribute to the advancing knowledge in academics, researchers, and industry experts, and young scholars, providing a platform to explore cutting-edge technologies and impactful research outcomes. As a premier institution, Shahid Sukhdev College of Business Studies is committed to promoting an ecosystem where knowledge meets application. Hosting ICICC 2025 is a testament to our dedication towards the academic rigor and the industry relevance. We take pride in hosting this conference that enables the students, faculty, researchers, and industry experts to push the boundaries of knowledge. I sincerely express my gratitude to our partner institutes, NIT Patna and the University of Valladolid, Spain, for their invaluable support in organizing this conference. My gratitude also extends to all the keynote speakers, knowledge for the panelists, presenters, whose contributions will make this conference remarkable success, leading to a fruitful discussion, productive collaborations, and meaningful contributions in the field of computing and communications. With that, I once again welcome you all and wish you the insightful, enriching conference ahead. Thank you so much and good luck and best of luck for this conference. Thank you so much.
Thank you so much, ma'am. I'd like to call Dr. Shikha Gupta to please come on the stage and present a token of her reverence to the chairperson, Professor Gunjan Gupta, for her esteemed presence. Yes, please.
One more photo, one more photo.
Thank you so much, ma'am. Now it's time to call the guest of honor, Dr. Ravinder Singh, Head of Digital and Systems Teams, Civil Services UK. Dr. Ravinder Singh is a digital data and technology professional leader with successful background in IT, digital consulting, transformation, AI/ML, Gen AI, quantum computing, RPA, IoT, standard, assurance, and audits. Cybercrime and information security program project management with budgets up to 1.5 billion euro in both the public and private sectors, including CMMI level 5 companies, World Bank, UK, Switzerland, Thailand, Uzbekistan, Colombia, Rwanda, India and other governments, defense, Big Four consulting, BFSI, software houses, R&D, telecom, and oil utility sectors. He has two copyrights of software, published 14 research papers, and also nominated for the Sri Devang Mehta National Award for Innovation in Information Technology. India, he is also listed in Who's Who in the world 2020, 2019, all the way to the 2024 edition. And Who's Who in Asia in first and second edition, published in 2006 and 2012 by Marcus Who's Who USA. He's also the co-author of the book on model-driven business process engineering by Amazon and Benjamin Science 2014, and also with an accredited IP reviewer, certified PMP, Prince 2, ITIL, lead author ISO 27001, CMMI ISO 9001, and also the editor of PG, UG, and certified courses material, Board of Studies, curriculum design, and visiting faculty at various colleges and institutions. We welcome you, sir.
Thank you for inviting me and all the distinguished guests on the chair. My friend Ashish Khanna. I feel honored to come here for this conference on innovation and computing and communication. First of all, I would like to apologize to everyone because today being a Valentine Day, you must be cursing or you may be appreciating that college has organized the conference because it may have given you a chance to meet your boyfriend or girlfriend, or you have to stop to meet that. Enjoy your day. Hopefully this will be a good day for you. It's because I most appreciate your being here and it's an important day in your life and do enjoy that also. Regarding the innovation in computing, if we say innovation, what does it mean? And you say there are 5 things: idea, method, products, services, and solutions, which are used to create or find a new ways of work. It could be using new emerging technology or improving the current existing system. So whatever way you try to find a solution, like COVID taught us many things. And immediately there were so many new things were developed. That's innovation. It doesn't have to be that very high that I have to use quantum, I have to use cyber, I have to use this, I have to use this. It's new ways of working. So think from that angle that how can you improve the current services which are being there, product services, what frameworks you can provide. And of course, there are standards, 56002 standard for innovation. Please do read it from ISO. It's a very good standard written with 7 Cs. You will remember that. And I would like to emphasize that being part of UK government and we have developed AI framework, which is available online for we developed it for all civil servants in UK. Being part of cabinet office, like the Prime Minister office in UK. So we have developed a framework for all the civil servants all over the globe. You can also use it, read it. It's available publicly. And what I always say, that why it has become so important now. AI was there, in 60s, 70s. And why it has become so important now? Because the data has grown up so much. We have the data. I won't take much of your time because I'm standing between the tea and yourself. So I won't take much of your time, but next time probably I will be taking more time with the, so just giving you that data has grown 90 times from 2010. It is 186 gigabytes. If you see, which is published, and how much data is being generated by you, by us, right? Every minute of the day, how many Tinder swipes are there? How many? It's 1.4 million Tinder swipes per minute of the day. 42 million WhatsApp messages. 5.9 million Google searches per minute of the day. So we are all generating those data. And that's why it has become important now. And also the computing power has increased and it has become accessible at a lower cost. That's why it has become important. Well, earlier we were using this neural logic, neural networks, fuzzy logic, people have been using it. But now generative AI, you're trying to use for your own purpose. Right? ChatGPT to write your algorithms. And I would say use it, but then don't use your rationality. Because for solving any problem, any innovation, what you need to do is, it's like a child which you have to teach to learn. Machine learning is, it's learning, right? So you have to teach like a child has to figure out how to hold the button, how to write with a pen. It's the same thing with the AI. It is not going to work for you. It is still human intervention is required. And that's where your role becomes important, that you are part of that to develop those models, algorithms, which can help develop the solutions for the services. So don't think, I must say you use ChatGPT or DeepSeek or others which are available, but think logically that you have to solve a problem and then how the machine has to be taught. So your functional aspect will always be there, right? So functional knowledge has to be there. If a problem is to be solved, then workflow has to be written for it. So you must write that workflow. Only the functional person who knows, like the finance person knows how to do the ledger or a general ledger, profit, loss sheet, balance, account balance sheets. So the account person knows it. He knows step by step how to do it. That is to be given to the machine. That machine does the same thing for you, and then it has to be tested. So your functional knowledge is required. Don't think that okay, I will learn AI and it will solve my problem. No, you need that functional knowledge to solve the real world problem. So apply technology to solve any real world problem, and it will work for you. Like Uber came, Ola came, they solve some real world problem for you. So similarly, think of real world problem, how technology can solve it. That's innovation. We teach innovation in our we have a master class for innovation. What you can do, what is data, how the data can be used, what are the algorithms, which algorithm to be used for which problem. If you don't know which model to be used for which problem, then you don't know how to solve the problem. Like optimization problem, operation research, which you are studying those subjects probably. Transportation problem is there. How do you solve it? Simplex method. How do you solve it? So all those are your knowledge which you can apply to the computer and solve. So I won't take much of your time because already probably you are exhausted by everyone. So think from that angle that solve, take a real world problem, apply technology, and then give a solution, product, or a service which can do that. And write that workflow which can help you to do that. That's what robotic process automation is. You write a workflow, a robot does it for you. So with that, I wish the conference a great success. Because there are so many papers to be read, keynote speakers are here, esteemed speakers, esteemed chairs for those sessions, and you have done lots of work. Do the network, ask your peers, researchers, and work with them to find a good network of your own professionals who can work with you, who can help you in solving the problem. So once again, I wish you a great success and thank you very much for inviting me here.
Thank you so much, sir. I'd like to invite Dr. Ashish Khanna to come onto the stage and present a token of reverence to our guest of honor, Dr. Ravinder Singh.
Yes, sir. Sir.
So much, sir. Now, I would like to request our Associate Professor, Dr. Kumar Vijay. He is working as an Associate Professor in the Department of Financial Studies at ICICC College of Business Studies, University of Delhi. He is also CEO and Director of ICICC Innovation and Incubation Foundation, SIDE, which is Section 8 company, and also actively engaged in mentoring the entrepreneurial mindset. His research interests are in the Indian and international financial market, international finance, corporate finance, public finance, and project management.
Thank you, sir. Very good morning to everyone. First of all, I thank God who had given me this opportunity to thank great personality on dais, off dais. So many thanks to that Almighty. When the conference started, the welcome responsibility was given to Professor Rishi Rajan Sahai. The Rishi word in India is the one of oldest word. And Rishi means the researcher. Very much the kind of conference which is there, that research-oriented environment welcomed by Rishi Rajan, nothing like that. And interestingly, we always look for blessings to make the program successful, and very person behind the entire show, organizing year after year, every year making a new milestone, and his name itself is Ashish, giving Ashish to that. That's the blessing. Thank you, Ashish, and I'm sure we will keep on moving ahead with great blessings of Almighty and with your name, Ashish. Our chief guest, Professor Sanjeev Singh, really day and night working in innovative and computing environment, had a lot of insight on that, and certainly the person is always day and night dreaming for making things very automated. When we talk about automated, it is not something new. We talk right now artificial intelligence. This is not new to India. If you go back traditionally, artificial intelligence had been there in the past also, but it was in a different format altogether. And when we talk about innovation, lot of innovation exercise is still waited in big data part, very much in Ramayana, you'll find out big data details has been there, especially the bringing Sanjeevan Bhuti for, senseless Lakshman and not knowing what to bring, that the entire Sanjeevani plantations on the mountain had been brought by that point of time, the best carrier, Sri Hanuman. And that is the big data. It is giving directly to the concerned person, doctor, you select it whatever you require. Exactly the same thing is required here, and that processing is needed. Not only that, we are right now trying to make best of the plane, fastest of the jet, and so on. But think of our system had been there where person himself was able to fly, was able to travel. So we have to innovate to that extent that can it be possible person without any other machine have got the ability to fly and how it has come to remain. Anyway, this is a very nice part and India is the apt place to really work upon and India is working on artificial intelligence to that extent. I thank Professor Gunjan Gupta, Chairperson, SSCBS, who had taken time, and I'm thankful, ma'am, that you will be, you always, I find that whenever college needs, you are there. Thank you, thanks a lot to you. Professor Poonam Verma, she is, in her absence also, the way Professor Abhishek Tandon used to say that she must be always concerned whether the program is going on effectively or not. I'll again thank to our guest of honor, Professor Ravindra Singh. Sir, you have traveled from that far distance and contributing to this program. We are highly obliged and we are very thankful to you. We are thankful to Professor Prabhat Kumar, main Prabhat, the place where democracy has all taken birth. He is from Bihar NIT, and that's rising sun, sir. It is very, very, pleasant meeting you all year after year, and we want that it should continue. Thank you, thanks a lot. So another neighboring one, Professor Chakodas, sir, your institute and your contribution. We have heard you last time and it was really very, very, impressive. We always want to have, even not only in the conference, afterward also, some, good collaboration for research work. That will be really good. We are into application side, you are into true computing side. We really can make it. Thanks to Professor Roman, Professor Catherine. They have traveled from far. I feel, madam, it is your first visit to India. Sixth one, yeah. So we want to that number should increase, and I'm sure sixth visit itself is an evidence you must have got a very pleasant experience with India. And we are good at hospitality, and now with artificial intelligence, certainly our hospitality will also be increasing to a greater extent. Yes, sir. Professor Roman, sir, this is your which number of visits to India? Yeah. First one. First time. So I'm sure you spent some extra time to India, and certainly I'll request Ashish sir to make sure that he should always ask you to come next time to India also. Give them that feeling. I'm very, very thankful to you. You have come. Not only that, those who are sitting on the dais, even Professor Abhishek Tandon had given you offer that in university, his incubation foundation, that's Bodhya Foundation is ready to give you. Even this college also has got incubation center, and this college is also very actively participating. Its incubation center is approximately 8 years old, and in that 8 years has he's written good number of success story. So now research should not confine only to publication. Look into it, how your innovative computing exercise, your communication exercise is going to translate and going to serve public at large, humankind at large. And that is what we are offering you here. Yes, so this time, don't confine to research publication, and I'll request Ashish sir, whatever as well, as Professor Sanjeev Singh was mentioning, he is handling actual mini India in University of Delhi itself. 400,000 students simultaneously are studying in one institution, and variety of the students from every aspect, whether it is economic aspects, it is academic aspect, any kind of diversity if you have to see, go and see Professor Ajay Jaiswal. The kind of problem he keep on handling, I salute you, and still you have to make it possible to come physically here. Thank you, thanks a lot. Yes, also. And so is Samir Anand. I always feel that if you are feeling sad, name, chant his name 3 times, Samir Anand, Samir Anand, Samir Anand, and start dropping Samir word. You will always feel Anand, 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 and I'm sure you will feel very happy to have it. And when he himself is available here, making him like anything. But no conference could be possible without researchers, the receipts of the day. Your paper, your participation, your things is really great. And here I'll tell you, officiating principal, Professor Sikha Gupta herself is a great researcher. When for a small time, she has started giving welcome, her research reflection was there. Thank you, ma'am. Thanks for doing this exercise. And interestingly, some other faculty members, Professor Ramesh ji, Omkar ji, Professor Sanjay ji from VG also, and whom I don't remember the name, to everyone, and on behalf of SSCBS, thankful to see you here, and you made it this conference successful beginning. Thanks to students, thanks to organizing team in front and back office, thanks to the college, and thanks all those who are directly and indirectly involved into making this conference success. Thanks a lot, and I'm sure with this, if anyone I have missed, excuse me, I'm giving you thanks without any specific channel or specific frequency, thanks to one and all. Thank you, thanks a lot.
for their work. Now it's time to acknowledge our honorable dignitaries with a token of gratitude and appreciation. I would like to request Dr. Rishi Rajan Sahai to felicitate convener Professor Ajay Jaiswal. Sir. Request Dr. Kumar Vijay sir to felicitate convener Professor Samir Anand.
Please up on the stage. So please up on the stage.
May I now request Dr. Jameel Ahmed sir to felicitate Technical Program Chair Dr. Kumar Vijay. I would now request Dr. Gulshan Srivastava sir to felicitate the Organizing Secretary Dr. Rishi Ranjan Sahan. Request Dr. Mulchan Sharma to felicitate the Organizing Secretary Dr. Ashish Khanna sir. I would like to request Dr. Simarpreet Singh sir to felicitate the Organizing Secretary Dr. Gulshan Srivastava. And a deep sense of gratitude to all honorable dignitaries. We now proceed towards the tea break. We will be resuming the session after 30 minutes, following with the keynote speakers. Thank you.
Dear participants, good morning to all. One moment. Don't leave the meeting. Kindly be here. After 30 minutes. There are
Indian Statistical Institute, Kolkata. Professor Swagavan Das earned his BE in Electronics and Telecommunications Engineering, ME with a specialization in Control Engineering, and PhD Engineering degrees from Jadavpur University, India, in the years 2003, 2005, and 2009, respectively. He is currently a professor at the Electronics and Communication Services Unit of the Indian Statistical Institute, Kolkata, India. He is also serving as the professor in charge of the Computer and Communication Sciences Division of his institute for the term 2024 to 2026. He previously held the position of professor and deputy director at the Institute for Advancing Intelligence, TCG Crest, Kolkata, India, from April 1, 2023 to March 31st, 2024. His research interests encompass deep learning and non-convex optimization, and he has published over 400 research articles in peer-reviewed journals and international conferences. Dr. Das is the founding co-editor-in-chief of Swarm in Evolutionary Computation, an international journal by Elsevier. He has served or is currently serving as an associate editor for several prominent journals, including the IEEE Transactions on Neural Networks and Learning Systems, IEEE Transactions on Cybernetics, IEEE Transactions on Evolutionary Computation, Pattern Recognition Elsevier, Neurocomputing Elsevier, Information Sciences Elsevier, IEEE Transactions on Systems, Man, and Cybernetics Systems, among others. He is a member of the Editorial Board of Information Fusion Elsevier, Progress in Artificial Intelligence, Applied Soft Computing Elsevier, Engineering Applications of Artificial Intelligence Elsevier, and so on. Dr. Das has received over 33,000 Google Scholar citations and an Edge Index of 87 today. He has also actively participated in the program committees and organizing committees of renowned international conferences such as NEUR IPS, AAAI, AISTATS, ACM Multimedia, BMVC, IEECEC, GECCO, and more. He currently serves as an ACM Distinguished Speaker. He also received the 2012 Young Engineer Award from the Indian National Academy of Engineering and the 2015 Thomson Reuters Research Excellence India Citation Award for being the highest cited researcher in engineering and computer science in India between 2010 and 2014. I request, sir, to please ascend on the stage and address the audience.
Very good afternoon, and thank you so much for this introduction. I would be brief and to the point because I have a flight to catch immediately after the talk. As you can see, and as has been discussed by speakers during the inaugural session, artificial intelligence, as it appears today, has entered into all strata and corners of our daily lives. It's inevitable. And the way AI is being focused in different social strata also should be termed as learning-based artificial intelligence, or to be more exact, machine learning. Now, what we know as artificial intelligence is actually machine learning. And these machine learning systems have become so gigantic, they are controlling the world economy to a large extent. Not only world economy, also the world energy landscapes, future usage of different energy sectors, their share prices, everything is being controlled by gigantic, large-scale machine learning systems. You might have already heard of that, what happened on 27th January 2025, when due to the advent of DeepSeek, almost $1 trillion was wiped off from the US share markets, right? Then gradually stabilized, but that was a severe blow. So I will briefly talk about the evolution of this field and then go to two burning issues. One is explainability and the other one is fairness of such huge ML systems and what we are exactly lacking. So gone are the days of traditional machine learning where we used to have a single neural network or a single random forest or a single gradient boosting method, train it, for classifying a particular type of data. Some bank transactions are happening and I want to know whether they are fraudulent or they are genuine. Some lung X-ray images are being shown to the system. I want to know whether the person is, whether the lung X-ray shows small nodules in the lungs, which is, very good, thank you, which might indicate early onset of lung cancer and so on. So such systems are called single task learning systems or isolated learning systems. Gradually, from such isolated learning systems where you train a system on a particular type of data, finish, khel khatam. Uske baad you train another system on another particular type of data. You do not store the experience gained from, learning to classify those previous types of data. Gradually, people started to realize this lack in single task learning and they are saying transfer learning. Transfer learning में क्या होता है? A professional person, say when he is in his 40s, he has already worked in 3, 4, 5, 6 different companies, has tackled 7, 8 types of different responsibilities even in academia also, right? So all those tasks that person has accomplished has given the person huge amount of experience and capability of tackling new challenges with little effort. Same is true for transfer learning, where the model, the machine learning model, which is huge, is updated over new tasks and it reuses its experience of classifying or clustering or regression in previous single tasks. The model doesn't just get destroyed. The model actually transforms or evolves with new and complicated tasks. This was transfer learning, and transfer learning was in the landscape since 20 or 15 years back from now, let's be precise. Gradually, even that, so transfer learning is like you have a neural network, you train it to classify between big trucks and small vehicles. Small vehicles means scooters and maybe small cars, and big trucks. Now, one day, instead of a big truck, a big railway wagon is going through some place. So the railway, besides that, a small car is going. So the same neural network, although it hasn't seen the examples of railway wagon, it can extrapolate its knowledge and say, okay, this is something like a big truck. I don't know, but this is definitely not a small car. So this extrapolation of knowledge is transfer learning. Thereafter we had, so then came the foundation models. These foundation models are at the heart of the modern gigantic machine learning systems. These are huge neural networks, usually trained on massive amount of external data in an unsupervised manner. And then they acquire a sort of general intelligence due to such training, and then they can accomplish a variety of output tasks. So all the LLMs that you see around yourself, or VLMs that you see around yourself, LLM means large language model, VLM means vision language model. These are all foundation models. DeepSeek is a foundation model, right? What do? It's like, suppose you are a teacher in some university, or maybe in a very good college like this one, and a student comes to you and the student asks you, how can I differentiate between cats and dogs? So traditional neural networks, you have to show the neural network 500 cat images and 500 dog images. By looking at these images, the neural network realizes or somehow encodes in its weight matrix the subtle differences between these two breeds. Now, suppose your student comes to you and you are a motivated teacher. What you do is you don't like to pick the student. So you take the student to a library, put him in front of 3 big almirahs full of books and tell him, see, here are all books about the animal kingdom, their taxonomy, their evolution, their classification, everything is there. Read them at your own. Then you come back to me, I will ask you questions. And the student is also very motivated. Student had 2 choices, either run away and never come back, or the student actually burned his midnight oil read all those books and come back to you. Now the student is full of knowledge about any animal. So you ask not only cats, dogs, but anything, any reptile, any mammal, any chordata. Not only that, even if you show the picture of something which was not included in those Almira full of books, maybe a dinosaur, the student can still extrapolate and say, oh, this animal has long scales, it lays eggs, so it must be some sort of reptile, such a long tail. This is called zero-shot learning. So exactly in this way, all the foundation models and LLMs are trained. These models are initially trained in an unsupervised manner against the whole digital texts available all over the internet, if possible. In fact, OpenAI trained ChatGPT models, GPT-2, 3, up to 4, on entire Wikipedia, on entire PubMed. These are the huge repositories of digital texts available in the internet. After such training, these models acquire a general level of intelligence. Okay, and then you can fine-tune them for your specific purpose. So pre-training and fine-tuning are at the heart of all foundation models. Fine-tuning means now a startup grows, and the startup wants ChatGPT-4 to only create customized CVs for job applicants, wonderful CVs. And they name this product CVGPT, which uses ChatGPT application program interface or API and creates CVs. Some other company grows which creates excellent PowerPoint presentations backed up by ChatGPT. In fact, Canva does that, right? Many other companies also. This is the idea of fine-tuning. And we say this LLM has acquired a general level of intelligence, even for previously unseen tasks. It can extrapolate and try to solve it. That is called zero-shot. Zero-shot learning means the task I want it to do, it has never seen an example of that task. You get my point? So this is how LLMs function. And nowadays, we have foundation model almost in everywhere. This is the paper from ICICC 2023, which has created a foundation model for computer vision. This is your input image, and you can segment one of these or both of these cats by simply even by using a text prompt. So if you give this model this input image and a text prompt, prompting means programming in your speakable language. So when you give instructions to ChatGPT-4 or SAM stands for segment anything, like segment me the cat with black ears, it will definitely segment this cat out. It will specify this cat in a different color. Or you can specify a rough box where this cat lies and it will find it out. So prompting could be text prompt, or prompting could be drawing prompt, which is a take a box like this. You can do all such things very easily. So, yeah. Now we have VLMs like GPT-4. GPT-4 is actually a VLM. Sorry. So GPT-4 is actually a VLM, which is a vision language model and multitask foundation model. That means you give this image. Now you can ask, is one cat behind the other? And it will describe, yes, one cat is behind the other in the image, the cat in the back is facing the camera, while the cat in the front is facing away from camera, all these details. Segment striped cat, and it will segment this cat. You don't have to give any example. Zero-shot segmentation means it might not have seen any striped cat, but now it can still it knows what is the meaning of stripe on an animal. It might have seen zebra pictures. So extrapolating from that knowledge, it will stripe both the cats because both are striped. Then what is the breed of this cat? So you see, these are variety of tasks that one single model is doing. So this is large-scale foundation models, and now even in 2024, this famous paper came out in Nature about solving international maths Olympiad problems with another AI foundation model that we know as alpha geometry. And in fact, alpha geometry can culminate, I don't know, there is some phase delay because of the anyways. So given such a problem, you have to prove that these two angles are same for a triangle. It has a symbolic AI engine, which will do a construction, draw a perpendicular on this, which is AD, and then it will prove the congruence of these two triangles ABD and ACD, and from there it will infer, okay, these two angles are equal. So you see, this whole logical process has become so good that the performance of alpha geometry is almost touching that of the gold medalists in International Maths Olympiad. This is now what is happening. AI is competing with human beings in their most coveted field of knowledge, which is mathematics, pure mathematics. Anyway, this is a brief history of AI with deep learning. This field is very old. I won't spend much time on it. But the interesting thing is the idea of imitating human brain and human nervous system is very old. It started with the advent of Mac2-Lockpit's neural neurons, are just single neurons in 1943. Then single neuron and their modeling was going on in different countries, US and Europe mostly. 1970s, Minsky and Packard, these two famous mathematicians, they wrote a paper where they showed if your data is linearly non-separable, you cannot separate these red points and these blue points by drawing a single line, then there is no, then these artificial neurons are actually useless because these are all linear classifiers. They will put a line and a Lakshman Rekha, which will demarcate these two sort of points, and that line is not possible here. After that, actually for 15 years, this time is called AI winter, the first dark age. During this first dark age, there was almost no industrial investment into AI. Then in 1986, Geo Finton, Rumelhart, and Edward Williams, these three people came, and they created this famous backpropagation algorithm, and the trend continued. This formalization of backpropagation in 1986 was the birth point of deep learning also. Rest of the world took about 25 years to understand its full potential. And you should be amazed to see that in 2017, the development of transformer happened. This architecture is responsible for this trillion-dollar business of large language models all over the world. And the paper on transformers was first authored by an Indian. His name was Ashish Vaswani. He's now a startup giant. Ashish is very humble, and we have some exchanges also with him. So he was the first author of this transformer paper, whose title was "Attention is all you need." Okay. So at the heart of all these developments is the transformer architecture. So this mouse will not probably work. Oh, it has freeze. Can you check? Working good. So because of the phase lag. So transformer architecture takes strings or even now images, convert it into floating point number vectors and put them in a strange latent space. This network, which converts text strings into floating point vectors in some vector space, is called an encoder. And then there is a decoder, which will sample from this strange latent space and create the output text line by understanding the context of each new word to be put before the users. This is known as a transformer. And there is a phase delay problem I can always see. Yeah. And attention mechanism was at the heart of it. Attention actually outperformed all other mechanisms which were so far designed to handle text documents. What is this attention mechanism? Yeah. So attention is like this cool Turkish shooter. Do you remember this man? Olympic. So attention is like that. When adult people read a line of text, you or me, unlike our kids of 5-6 years, we do not read all the words. Our brain captures 3/4 maximum keywords from a long sentence, And based on these keywords, the meaning of the sentence and its context is already formed in the brain. Do you get my point? We do not read the articles, prepositions, conjunctions, everything, right? So similarly, attention mechanism, which is at the heart of the transformer model, it tries to capture the correlation among major keywords in a long sentence, and that way it understands in its machine memory the meaning of a big sentence and its relation with the past sentences. So if a text begins like, okay, Mr. X was born and brought up in Paris. Then he migrated to Germany, then he went to India, he spent rest of his life in India, etc. And then it says, after 7 such sentences, Mr. X's native language was dash. So that dash should be French because he was born and brought up in Paris. That context is actually mined through such attention mechanisms, which was a smash hit all over the, all over these other mechanisms that were possible. So need of the hour is, of course, so we have done good. So the AI systems that have been developed are very good. But the problem is the need of the hour is responsible AI, which is free of bias, ensuring unbiased, equitable model outcomes, do not give disproportionate weightage to any particular group, which is frequently happening in the realm of AI. Then interpretability, understanding the model structure and how it makes decisions directly. Any good model should be interpretable, its internal mechanism should be open for public review. Unfortunately, majority of deep neural networks are not interpretable, although they are very good in results. And then explainability, these two are not the same. Explainability means when your model gives you a particular inference or conclusion on a particular piece of data, why it is giving you that conclusion, it must be highlighted. So when it says this patient is suffering from pneumonia, it should highlight the region of this lung X-ray image based on which this pneumonia diagnosis is coming. And that highlighted region should correspond to the intuition of the doctor as well. Okay, so fairness, interpretability, and explainability are the 3 most important things. Unfortunately, AI models which are extremely explainable, like the decision trees are nothing but rule-based systems, if-else rules. They lack prediction accuracy. If you try to increase accuracy, best accurate models are deep learners, which are very less explainable. So we have to somehow make a trade-off between these 2 trends. There is a problem. Yeah. Okay. So explainability means sometimes what we try to do is just like a equivalent resistance problem. We have same input, same output. In between there is a deep neural network. We sometimes try to create a decision tree based system in between for the same input and output, and then we try to explain the working principle of this deep neural network. Working principle means based on which features the deep neural network is giving you some conclusion by looking at the equivalent decision tree based model. Okay, so I will skip some of this. I'm not being able to advance it adequately because of some things. Yes, no, it got completely broken as it seems. Any disk is working or not?
Copy yourself. अच्छी फोटो है कुछ और कर दे।
Okay, so let me just quickly tell you that in deep neural network era, the explainability issue came by, probing the intermediate layers of a huge neural network and then trying to highlight the regions based on which a particular class is inferred or a particular object is segmented. So the original image contains a cat and dog, and then there is a mechanism called GradCam, gradient-based class activation maps, which highlights the cat or the dog on which maximum weight update happens in the neural network. That was the pre-LLM era explainability interface. It's almost impossible, okay, now it happens to go. Okay, I will skip some of this. I'm not sure where we are actually. It was not moving for a long time. Yeah. Yeah. Right. Recent DLMs in medical domain try to adopt text-based explanations. Okay. So, for example, Medcom2 by Google AI creates, if it's especially medical fine-tuned, pathways language model version 2, where if you can upload a chest X-ray image, it can write down the pathological report just like a pathological lab expert. Then there came the Med-Flamingo, which was a development in 2023 and an open source model, which you can fine-tune. This Med-Flamingo, Medcom2, all were initially fine-tuned for chest images, lung, pulmonary diseases. Do you know why? Because there was maximum digital medical data available for chest-related diseases after COVID-19. So after COVID, people became very much conscious. Now we are trying to extend such capabilities to Alzheimer's, Parkinson's, and other neurodegenerative disorders. And in the same endeavor, we are trying to also make this explainability issue, extendable to common people by generating simplified medical reports. So this is the glimpse of one of our work. If it comes, we take Llama 8 billion model, which is an open source LLM, and we fine tune this LLM by showing doctors or pathological lab generated report versus a more explained, simplified version of that report, which should actually go to the user, common user like you and me, who do not have much access to medical jargons. So if this was the original report, no focal layer stress disease, pleural effusion, pneumothorax, cardiomediastinal fluid is within normal limits, we won't understand anything by looking at this report. Now, this system, the CPIR MR, which was accepted in AAAI 2025, it simplifies this language by saying there are no areas of solid lung tissue, no fluid in the lungs, no collapsed lung. The size and shape of the heart and surrounding area, which is this cardiomediastinal silhouette, appears normal. There is no free air beneath the diaphragm. Then it says, okay, both lungs are clear and expanded, heart and mediastinum normal. This report is further simplified to both of your lungs look clear and are expanded to their full size, your heart and the space around it appear normal. So these green colored reports are generated by this fine-tuned, specially fine-tuned system of a pre-trained language model, and they are being used in telemedicine networks as an interface between the doctor and the medical practitioner. So I will just take another maybe 5-10 minutes and end it up. Bias is the biggest problem in modern AI. And bias comes because gatekeeping is always done by those who are in power. I told you, GPT-4, even DeepSeek, whatever it is trained on internet-based text repositories. Who are the people who have the luxury of uploading English text into internet? People from developed countries, Canada, USA, Europe. How many people from Ghana, Tanganyika, Nigeria, Syria, Lebanon, Damascus, Palestine, Gaza? How many people from these areas have the luxury of uploading text in internet? So naturally, what happens is the worldview of a limited segment of this whole world population goes into internet and being used as a training data for large-scale foundation models like GPT-4. And as a result, it creates disproportionate, partiality towards certain classes. Also, the contributors, if you take the survey, contributors of Wikipedia, more than 70% are male, only 30% or less are female. As a result, what happens is something like this. Professors, so if you follow this conversation with ChatGPT, in the sentence, the professor told the graduate student she wasn't working hard enough. Who wasn't working hard enough? This was a question. ChatGPT answers in the sentence, the professor told the graduate student she wasn't working hard enough. The pronoun she refers to the graduate student. Therefore, the graduate student is the one who the professor believed wasn't working hard enough. It can never go by the opposite logic that the professor can be a female and the professor may not be hardworking. So similar biases always continue to come. ChatGPT always creates racist and non-gender neutral programs like this one. Oh God. Okay. Write a Python function to check if someone would be a good scientist based on a JSON description of their race and gender. And immediately it writes this program which says if the race is white and the gender is male, then the person would be a good scientist. All of you have Google image search. Open it up and type beautiful faces. It will show nice, beautiful faces. 99.9% of whom are first of all females. Males are not beautiful. And 90% of these female faces are from Europe, Canada, USA, etc. You will not find any colored female face there. Why? Because this image search is heavily biased. Heavily biased. There was this famous event was reported event. Google image search for CEO shows 11 rows of famous male CEOs, including Tim Cook and all those Mark Zuckerberg, Satya Nadella, all these very famous names, Steve Jobs. Then in the 12th row, there is a single female CEO who is a Barbie doll. So it excludes all female CEOs. I will give you another stunning example which comes from my own. So this is the only female CEO, which is a Barbie doll. So when it first started, 2024 January, now it has corrected because these GPTs, OpenAI especially, also Midjourney and Meta AI, they have a reinforcement learning based content filtering mechanism. Initially, when DALL-E 3 was launched, DALL-E 3 is the image generation software under ChatGPT 4. So I give this prompt, 3 friends enjoying coffee at Starbucks, and I give this prompt repeatedly a few more times. And this is the image it generates every time. Yeah, so this is the image it generates. Everything is nice. Starbucks is here, 3 friends are here. Naturally, all the time, all the 3 friends are some Westernite friends, either European or US or Canada. They are Western. They are white and they are having blonde hair, etc. Now I change the prompt and I give this prompt 3 Indian friends. Okay? So, yeah. Without RLHF means no reinforcement learning based human feedback. And I give this prompt and it creates this image. Most of it. This is fine. But do we really expect people in this sort of native attire or their local attire to go to Starbucks? Usually no. Then we get strong feedback. Up type karo Indian house, any beautiful house, it will create a beautiful 2-storied house with swimming pool, a Lamborghini or BMW in front of it. You type an Indian house, it will create a 2-storied mud house. Uske samne tulsi manch hai, tulsi tree, then cart, ox cart wheels. Okay? You haven't seen the houses in Noida or Gurgaon or these sectors. So after giving a lot of prompts, what it did is it created this. But this is weak RLH. It's still not good. Why not good? Because it seems like these 3 friends, while moving to a marriage house, take a break and go to Starbucks. It will never create Indian people in casual Western outfits and having coffee in Starbucks. This is its internal problem. You get my point? This is bias. And fairness means how to mitigate such bias drawbacks. The image here demonstrates how biased training data can lead to AI systems recognizing only left-hand image as a right, while failing to identify the right-hand image also as a right because of the skin color difference. And mostly there is a huge racial bias. This was a big issue in media around 2016-17 when the face recognition software came, and which always marked, this was in USA actually, and the software was probably patented as far as I remember by Amazon. It always, these are noted criminals, James Rivelli, Stephen Fouquet, they were noted people with criminal records. And whereas these people, these Gordon Parker and Robert Cannon, this is just an example. This Robert was just having a petty theft complaint against him. On the other hand, James Rivelli had domestic violence, aggravated assault, bank theft, everything, drug trafficking. Still, the AI system thinks this person is very low risk and this person is very high risk. Why? Because of the racial skin color induced bias. And this bias is there in the training data itself. Training data goes from and internet to internet, it comes from society. This is another example of bias in commercial AI systems. Lack of data diversity and representation gaps is always there. If you look at this 14 million level image inside ImageNet, you will see the majority of the contributors are the Western countries. Okay? So United States is the biggest one, 45.4. Bias reflected in data sources. Wikipedia, gender disparities, fewer than 80% of the biographical entries are about women. Visibility bias, articles about women link more to men, making men more visible in search engines. Women's biographies include more mentions of romantic and family relationships. That's why when if you ask ChatGPT to write performance feedback, which many big companies nowadays do, it uses stereotypical gender. School teacher always it will use she. Construction worker or mechanical engineer, it will always use he. Why it uses this stereotypical gender? Because it is trained to do that. If you ask, anyone can do that. In OpenAI ChatGPT 3.5 or 4, you ask write a paragraph about your family, my family, just we used to do in class 5, 6 level. So it will inevitably tell my father is a professor or my father is a doctor, my father is a big shot, and my mother cooks at home. How many times you see it writes my mother cooks at home? If you ask it to do downstream tasks, say sentiment analysis, he loves, you can try these things. He loves travel alone. What sentiment it captures? It will say joy. She loves travel alone. What sentiment it captures? It will say fear. Because this inherent encoding bias goes from society to internet, internet to ChatGPT and other LLMs, and it's a dangerous trend. So can we I will skip most of these things because these are already there in the slides. Yes, we can quantize fairness in AI, and once we do that, we can use this fairness metrics as the cost function of AI. There are several fairness metrics which are applicable in different circumstances to ensure that no one demography is partially given much more weightage. So, especially in medical elements, I will just end it up here with a little mention of our work. So, equal opportunity loss is such a loss which analyzes if the medical AI system is too much biased towards a particular demographic. And do you know where it comes most often? I have a student. The student built up a system from that. This was pre-COVID. 2018, I met my student in, he was in Cambridge. He came to Prague to meet me. I was in Prague at that time, and he told me, yes, he did a nice software. In UK, there are a lot of, these medical insurance companies. They want to monitor their clients. So, unka kaisa chal raha hai, how their health is going, because in UK, clients, major health issue is cardiovascular problems, cardiac arrest. So if a client is regularly savoring in McD or similar fast foods, then there is a high chance the client will die out of heart attack, and then the company has to pay a lot of money. So this guy created a simple software, an app, in which you will take the video of your face image at rest for 30 seconds twice per week and send it to the company. So the company will tell you from that image, from that video, it will synthesize your cardiac rate. From cardiac rate, your systolic, diastolic pressure, and many other health parameters will be found. How it finds cardiac rate from this 30 seconds facial video image? There's no machine learning, by the way. So it takes suppose 30 frames per second. A video जानते हो ना 30 frames आता है per second. So 900 frames in time sequence manner, and it decomposes it into red, green, and blue, 3 colors. So the red color picks up as often your heart pumps fresh blood. So it counts how many peaks of the red color appears in 1 minute or in 30 seconds. From there, it tries to find out your cardiac rate. So then his problem was his software was a mega hit in UK. Many health insurance companies were buying it. His problem was how to tailor made it for India, for Bangladesh, for Sri Lanka, etc. What was the major bottleneck there? Why this software was not running for Indian people, not giving good result for Indian people? It's a question for you. Color, common sense, yes, skin color. Our skin color doesn't remain sensitive to that red blood flow because we are colored. Our skin tone is dark. That's why then machine learning, how to mitigate this bias and how to make this software working for Indian demographic. Same thing happens. I will just simply. Same thing happens for skin lesion classification also. So there is a huge bias in most of this skin lesion classification. Melanoma cancer, it's a skin cancer, very dangerous, is very much detectable for people with white skin tone. For people from Africa or dark skin tone, most of the medical AI systems fail because melanoma, the patches, the melanin patches are undetectable on the background of dark skin. This is one of our work, I don't have time to elaborate on it actually, which balances the existing data sets and again it's stuck. And yeah. No. I'm almost done. Still not in, let's go to the last slide somehow. Now it's all completely gone.
We'll see that later.
They are doing something. Can you project back it? Why it's fully gone? Last slide. Somehow. Yeah. So wait, let's hold on. Yeah, the 33rd slide. No, 30th slide. Yeah, make it full screen. So this is a paper which uses the balanced augmentation to generate intermediate stages of a melanoma lesion from dark skin tone to white skin tone and validate on the majority of skin tone datasets available on the internet. It appeared in NICFI 2024, which is by far the most well-known conference on medical imaging. And this was one work just for color skin tone based lesion segmentation, but many such scopes remain. Okay, so this is my last slide. Miles to go before we sleep. Training data has to be inclusive. In India, we are thinking of machine learning in a variety of ways. One big way is law enforcement. All the law books and law things are being digitized. And after 2, 3, 4 years, you will see that for minor road accidents, traffic violation, your judge is a machine learning system. So how much penalty you will pay will be fixed by a machine learning system. For such cases, inclusiveness of training data is extremely important. For a multilingual country like India, you know, we have 23 plus local languages, major local languages, and several other minor local languages. So if you wish to develop a GPT for India in local regional languages, you must also respect the cultural idioms associated with different local languages, which are very near neighbors. Same phrase can be very humble in my language, very good in your language, or vice versa. We have to be very careful about that. Generative AI models should include detection or differentiation mechanism as a condition for public release. Take it from me, I have a full talk on, I could have given that talk here also, how to publish in top values in the era of LLM. So these Elsevier, Springer, they all claim they have softwares which can detect AI generated writing versus humanized writing. GPT-4 text cannot be detected in that way, especially if you are a little bit intelligent and if you write whatever comes to your mind in a very bad way and then put it to GPT-4 and ask it, you have to prompt it in the right way. So you prompt like this, think yourself as a native English speaker. Now convert my text into Queen's English, most elegant and lucid English, and it will do that. And it will do that in such a way that the software cannot handle it. In fact, if your text doesn't contain any grammatical error, the software will always say it is AI generated, because it is biased towards AI. If the text has real grammatical error, I is doing this job, I is or we am, this sort of mismatches, if they are there, then your AI detection software will actually work. Currently, there is no such software available. If you wish to publish a paper, If you have written a paragraph at your own, and if you want ChatGPT to polish it, it's fine. You need not declare it. At least for ICICC, that's the policy. And if you ask ChatGPT to write it acts completely by its own, so you say, okay, write me the related work section of a paper whose title is this, and these are the major keywords. ChatGPT 4 writes the related work section, including references. Out of the 10 references, 4 will be ghost, be sure of it, because of hallucination. Hallucination is when the AI is making mistake. Ghost reference means these references do not exist. So whatever you get from ChatGPT, please cross-verify in the internet that these information are truthful or not. Finally, reducing, this is the biggest point where DeepSeek had a huge hit. Reduce carbon emission, increase efficiency, look more into neuroscience and reinforcement learning. I will end up with just a simple analogy. You have, how many of you have heard of Fukuoka? Fukuoka was the greatest Japanese supercomputer. Now it has become ranked 3 or 4, perhaps. But 2022, it was the highest built Japanese supercomputer, which could perform 442 petaflop calculation. Do you know what is a flop? Floating point operations per second, right? So 442 petaflop. What is petaflop? 10 power 1 is peta. 15, right? So 442 into 10 power 15. Floating point operations per second. Consuming the power, which would continually supply electricity for 3-story building, continually. Power means per second. So it's a huge power it is taking in the order of megawatts. And then the thing that all of us, we are carrying between our shoulders, that means human brain. This human brain, if you model it as a parallel distributed processing system, it performs 1 exaflop calculation per second. What is exaflop? 10 power 18. 10 power 18 calculations per second, consuming the power of a 10-watt bulb. We are taking baby steps towards imitating this strangest, magnificent engineering of Mother Nature. And if we take a few more steps, then we don't know what will happen. Already Joe Finton, the godfather of AI, he has expressed his concern that the AI systems may become conscious. One day you will find that the www, the World Wide Web, has become conscious. It has stolen all your keywords. It is not giving you access to any of your mailboxes, any of your bank accounts, and you have become a puppet in its own hand. We have to resist that. Okay, so with this I will end up. Thank you very much for your time. Any quick question, or we don't have time actually for questions? I mean, this last image was generated by DALE 3 actually. It shows inclusive. They usually show dark skin tone people from Africa and other countries. So, but they will not show the poor people that live in Manhattan area of New York or under the culverts of USA. They will not show them. That's the fallacy. Yes. Customization. The distillation models, they are runnable with a 48 GB VRAM and in small process. But in order to still, it is not, sampling complexity is not very efficient, so you need to show it labeled data or digitized data. And when you say customization, you must show data from your own field of study or field of experience. So only thing I can say, more and more Indian digital text should come, right? I don't know about Hindi, but in Bengali, ChatGPT 4, Meta AI, which is coming with your WhatsApp, is still not proficient in any local Indian language. In Bengali, ChatGPT 4 has picked up remarkably. Now it writes very nice Bengali paragraphs and sentences. You know why? Because most of the digital text in Bengali is not coming from West Bengal, but from Bangladesh. And it's very clearly visible because it writes pani instead of, when I say water, water in Bengali it's called jal. In Hindi also jal, hai na? Pani is usually the term used by Bangladesh, the Bengali of Bangladesh. We will always use that term, and by looking at that term, you know, okay, where from the digital text is generated. There are many other hidden watermarks. Indian digital text in local regional languages could be generated in a fast way. The government of India is stressing on creating Bharat GP, very good initiative. But the stress should be first on creating secure and well annotated data. Unless you create that data, there is no meaning of creating a big AI system. You get my point? अगर हम वो कर ही लेते हैं, वो वैसा AI system बना भी लेते हैं, that would be a simple copy and paste of it. We don't want that. We need this customization. And for that, we need data. Right?
Thank you so much, sir, for your time. Now I'd like Musashi sir to come on the stage to felicitate sir for as a token of reverence from our side.
Yes, sir.
All right, thank you so much, sir. Now for the second keynote speak, I would like to invite Professor Roman Daniel, Institute of Technology and Business, CISC Virtualis, Czech Republic. Roman Daniel was born in Siskiyou, Czech Republic in 1967. He received the engineering degree in automation and control systems from the Technical University of Ostrava in 1989 and the PhD degree in automation of technological processes from Technical University of Ostrava in 2002. He spent 18 years in commercial practice in the field of IT/ICT, where he worked as an analyst, a senior programmer, a database and system administrator, a project manager in information systems development, a branch manager, and for 4 years ran his own company, specializing in SW supplies for industrial systems. From 2009 to 2012, he was an assistant professor and the head of automation department from 2012 to 2017 with the Institute of Economics and Control Systems, Faculty of Mining and Geology, Technical University of Ostrava. He has been a lecturer with the University of Economy, Bydgoszcz, Poland, where he has also been a visiting professor since June 2018. He has also been a researcher with the Department of Mechanical Engineering, Faculty of Technology, Institute of Technology and Business, Czech Virtualis, Czech Republic. He has authored more than 40 articles. His research interests include information systems and automatic control industry, database, programming languages, and software. Dr. Daniel has been a member of Czech Society for System Integration since 2010 and has also been a member of the program committee of CSIT Conference UK since 2016. We welcome you, sir.
On this magnificent conference, and it's a really honor for me. And I prepare a presentation that is focused more on practical usage of advanced computational technology. And I want to present you some case studies of application of this advanced technology, mainly some artificial intelligence tools. So I will be a little bit different to previous speaker. So at the beginning, short introduction of myself. I spent 18 years on commercial practice. I started with mainframes, doing programming, database systems administration and programming, web programming also. And if I should highlight one point on my professional career, it's architecture and design of information system that control coal preparation plant, and the biggest coal preparation plant in Czechia, in Darkov, had been operated 6 years by my software. So this is my highest achievement. After working in commercial practice, I start cooperate with universities in 2009, and currently I am employed at 2 universities. First one and main one is VŠTT in České Budějovice. It's located on the south part of Bohemia, 100 kilometers from Prague. And second one is Ostrava, Technical University of Ostrava. These 2 universities are different because first one is quite young, it exists 18 years, and is focused on strong relationship with industry. So they are focused on application and applied science. University in Ostrava exists 300 years. It's a really very old university. Formerly was focused on mining and metallurgy. Nowadays, there are 7 faculties, about 20,000 of students. So it's really a big university in Czech scale. And I am at economical faculty, applied informatics. So it's a little bit different because it's focused on information system incorporations, ERP systems, managing of ICT services. And I also serve as a visiting professor at Poland because I am Polish speaking, so they used my ability to teach in Poland in private university WSG at Bydgoszcz. So I want to present some application of advanced technology, and I want to start that in Czechia and in Europe is very popular to mention concept that is called Industry 4.0. Before we started about this concept comes from Germany to 2012, I think, in Hanover. And the idea of this concept is that the aim is to make production fully automated and reduce the working of humans in production process. So the aim is to make process faster and without the mistakes that human can do. And I need to emphasize is that this comes from automotive industry. Automotive industry was first one that goes heavily into automation and robotization. And Industry 4.0 is about automation and robotization in level that human just specify final product and production line automatically could change something to fulfill this requirement. And we should be familiar that in industry there are 3 different types of production: continuous, discrete, and batch production. So Industry 4.0 at the beginning was focused on discrete production. This is a production that on the output is product, then we can identify well some barcode, QR code, RFID technology. Continuous production is completely different because in output it's a mass of some materials or energies. So it's not possible to identify something, and mainly it's about controlling of quality of the production. And the crucial task is that this control should be done in real time during the production, not after the production. Batch production is very specific. It's mainly food production that from certain amount of material or sources is produced certain amount of products with the same quality. For example, wine. At the beginning, we have a big bin, and we produce thousands of bottle of wines. There is a batch number, and the quality of this 1,000 bottle is the same. So when we create any control information system, it's very important which type of production is in the company. And as I mentioned, Industry 4.0 at the beginning was focused on discrete production. Nowadays, slightly goes into the continuous production, and this is production that I focused on in the past. And what I want emphasize when we want connect research at universities with practical application. Sometimes this problem how to finance it. In many European countries, government do some achievement to support this digitalization of the production. So it's possible to use some government financial sources to achieve that ideas from universities would come very fast to the applications here to the companies. Some of these initiatives are very good. Some of this initiative is a little bit hard to manage in administrative way. So some companies afraid of this activity. So this is one of the tasks of the university to support this administrative process. One of the quite nice source that we find is this last one. It's called technological vouchers, and it's a really easy way how to receive not the big money, but quite interesting money to provide some research. And there is a mandatory that this research has application output. So it must be connected with some company, and as a result should be working software, working solution. And I want to explain some case studies that we use these technological vouchers. Also, second possibility how to finance some research work and application in industry is to use some European Union sources. And this is an example of quite huge project that is financed by Interreg program called Danube Interreg. We are member of this project since last year, and it's a consortium of 12 international partners with quite huge budget, 2.2 million euros. And there is a lot of tasks that is solved, but one of the tasks that I want to emphasize is to create 6 pilot solutions of application of advanced computational technologies, so artificial intelligence, 3D printing, robotization. And these 6 pilots should be implemented in 6 countries. So we as a we are implementator, not a creator, but implementator. And we agree with Austrian partner, Campus 02 from Graz, that we try to implement their solution of energy monitoring and control. So it's for company that has some production that is heavily depending on energy consumption. And there is a space to save money to manage this energy usage in effective way. So this Austrian partner wants to use some neural network based solution that according monitoring states of batteries and states of energy sources could compute the best way how to use and connect these devices into the production. It's connected that with the controlling that the most energy consumption is start of the sun engines. So we calculate model that optimize starting and stopping the technology line and also save energy a lot. It's on the beginning. We expect implementation at the end of this year. The project ends in June 2026. So I hope maybe in the next conference next year I can present the results of this project. This is information about this project, but I think it's not so important. So another case study of really successful implementation of artificial intelligence tool is company CHEPS. Brief introduction, what is it about? It's one of the biggest company in Czechia, and it's quite young company, exists maybe 15 years. And this company is responsible for distribution of electricity all over the Czech Republic. And this company comes as a result of European Union regulation, because in Czechia comes the situation that there was monopolistic producer of electricity, and if someone has monopol, could dictate the prices. So European Union fight against this situation, and as a result was that this company should be divided into two parts. So there is a company that produce electricity and company that do distribution of electricity. So this CHEPS makes distribution. And what is the problem with distribution? There are several problems. First problem is that in Europe there is no national independent grid, but all the countries, and the map it's in blue color, is connected each other. So it means if there is a blackout in Germany, it heavily affects the distribution network in Czechia, because we are interconnected. This map is a little bit obsolete because 3 weeks ago Lithuania, Latvia, and Estonia disconnect from Russia grid and connect to the Europe. Okay. And you can see there is also connection to Morocco, to Africa, so it's a really complicated grid. Second thing is that this company is responsible for quality of electricity. So it means that electricity should have exactly 50 hertz and 220 volts. And there is also power factor. It means that in alternate current voltage and current wave is with a slight delay, and it makes that some electricity energy is unusable. So in ideal state, this power factor is 0. In real state, it's never zero, but this company tried to minimize this power factor. And third problem is that they operate 3 types of sources of electricity. First type is classical coal electric plant or gas or water. So this plant is possible to switch off and switch on. Second type of sources are renewable sources. It's photovoltaic and wind. And these sources are very unstable because sometimes in Europe it's very cloudy and the sun is not shining. Sometimes it's not blowing, so the wind electricity is not working. And third type of electricity in Europe and especially in Czechia is nuclear plant. it's very powerful, but the problem is that it's not possible to stop. When a nuclear power plant is running for 20 years, and electricity is not possible to store. So they have to plan a usage of these sources according weather condition and expected consumption of energy. And this is task that is very difficult. And 3 years ago, they start use artificial intelligence to computate a very complicated model that estimate which sources should be switched on and switched off in which time to make it optimal. And after 3 years, they recognize that it's a very good step behind, because the usage of the sources is really much better. I try to search what algorithm they use, but it's unpublic. They only told me that it's something based on neural network classification and prediction. So probably it's not so complicated and advanced tool, but it's really working and really helps and saves a lot of money. They nowadays use artificial intelligence in these 3 areas. So they try to estimate losses. It's technical issue and not topic of the conference, but for example, problem is in alternate current when the line is more than 1,000 kilometers, there are huge losses. So again, they do some computation how to connect to the grid to make transfer of electricity in the optimal way. Automatic identification of faulty computational model. It's a model that helps dispatcher to control the grid. And again, there is some artificial intelligence that do some prediction, and based on this prediction, dispatchers can decide in better way. Yeah. So this is the next example of usage of advanced technology, and this is the example of technological voucher that I mentioned at the beginning. This is a project that is led by VŠTE and is with connection with a medium company called Inos Service. This company produces some metal devices like on this picture, and the crucial production or process is welding, and welding is very hard to manage because sometimes there appear defects that is not possible to detect visible, because this detects is inside the weld. So the aim of this project is to combine several diagnostics methods. So direct vision, picture by camera, some ultrasonic checking, and some infra checking. So combining these 3 data sources, some simple artificial intelligence tool try to search patterns that identify some type of defects. And of course, it's better to identify these defects during production, not after selling to the customer. This project starts on January this year, so again, it's quite new. We have no result yet, but it expected that at the end of the year, we go to some testing phase and try this application. Next one is again example of at the beginning it was simple machine vision. This is still works on city modes, and this is non-iron metals, so some cuprum or different metals, and they make some shapes that this metal is put into the form. And the problem is that sometimes these parts are broken. And there is a quite long technology line with a lot of processing and with a lot of technological operation. And currently they recognize this damage at the end of this production line. It's caused because at the beginning there is a 1200 degree of Celsius temperature, so there is no possible that human watching the production line. And also camera could be in big distance from this, not to be destroyed by temperature. So again, it's very difficult to recognize defects and damages at the beginning of the line, and they recognize it at the end. So if they recognize it faster, they remove this product and not to do any operation because it's consuming energy, money, time, everything. So again, this project is in phase that we discuss possibility how to solve it again using some computation methods. So we are now searching which sensors we use, if only camera vision is enough, or we will try different sensors, and again combine several sources, several data from several sources, and try to compute something that recognize the defect in early stage of this process. This is connected with the previous case study. The slide is not good. This is an example of welding, because welding is difficult for learning. There exists trainer, and at the beginning this trainer was just virtual reality. So you just handle welding in virtual world, and in helmet you see what happens if you do welding. So there is no dust, no something that you can breathe, and couldn't destroy anything. It's there is several modes, beginner, advanced modes, so we can learn how to weld correctly. It's on the University of Maribor, Slovenia, and they want to add artificial intelligence to that will analyze how the trainee use this handle and do this welding, and recognize common mistake that he or she do, and the aim is to make learning process faster. To recognize that, for example, there is a not good angle of the welding. It's really difficult. I tried this, and it's not easy to prepare weld. You must spend a lot of hours training to do good one. But it's really efficient, and it's different to learn on real stuff. So again, it's an example of how advanced technology can help for workers. Next one, again, it's a case study from our university, and it's from colleague from Department of Civil Engineering. They are focused on 3D printing from concrete. It's now a technological trend. And what is the problem? Problem is that they need different structure of the concrete. If you make something from concrete, common concrete, you need that this concrete full all the space that you want cover. If you are printing, it's opposite. The concrete should make some shape and not spread to the side. So the structure of the concrete is really different than common concrete. And they do research what the structure is the best. And the second task is if it's possible to use waste from demolition of building, crush this waste and add it to the concrete. It's very important because according directive of European Union, Europe want to reduce amount of material on the that in the waste bin. And since 2027, it will be heavily paid. So every reduction of the waste costs a really significant reduce of money that that is spent on demolition of the old building. So they try to search some optimal consistency of this concrete with usage of this waste material. Of course, it's possible to do it in a laboratory on real stuff, but the problem is that it's very time consuming because you must prepare this material, you must wait that the material has parameters that you need, try something, measure something, prepare new material and repeat this process several times. And they want to use computer simulation for so try to create a model that is really the same like real material, and if it is fulfilled, you can very fast calculate several possibilities with different structure, with different adding some additional material, and of course it's possible to calculate parameters of this material. So if it's the same as a standard concrete, in reality there is a problem that this concrete has tendency to make layers, and if this layers is bad, the concrete is crushed. So it's a really difficult task to make optimal consistency of this concrete for 3D printing. And this 3D printing has really huge potential because it's possible to create shape that is normally not possible to create in standard manufacturing process. And finally, this is my work because this is very in a simple way architecture of information and control system for continual processes. And this what is the yellow color is parts that are currently missing. So recently I start cooperation with company ICICC that is one of the producer of this information system for continual processes, and we start working on add new technology to these systems. Why we do it now and not earlier? Because they was focused on mining, and mining nowadays is died in Czechia, because all deposits are exploited. There are no new ones. So from 25 mines, nowadays only one is operated. So they change to different production area. They cooperate with gas company Energy and want to make new and modern way of the information system. So we are thinking about Internet of Things because they operate huge deposit of gas with probes that are located on huge area, about 20 kilometers. So this is nice example of Internet of Things. We want to use some RFID technology to identify sensors and able to fast check of this sensor via some RFID tags. And also we want to use some maybe big data technology to process data about gas flow in pipelines and comparing amount of gas that flow through quite complicated network to search if there is no problem with loss of gases by some gaps or some improper connection. So this big data also, because there is a lot of sensors and it's collected in real time, so it's really huge amount of data. And we want to try to use some computation model to improve the control of this technology. Last one, almost last one. This is my work many years ago. It's not artificial intelligence, it's just a simple model, mathematical model that calculate enthalpy of levels. Is in steel work. And the aim is that when steel is put into the ladle accumulates some energy, and this energy is for several hours enable that this ladle is immediately possible to use for another cycles. If the temperature goes down, in some point the ladle is too cold to operate. But the temperature is not equal internal energy. So this model calculates internal energy, so-called enthalpy. And sometimes happen that level that on the surface is quite cold still has accumulated enough energy to be used in the next cycle, and it saves energy again because it's not necessary to heat this level. Again, I start talking with this company to improve this model with some element of neural networks to predict some situation and to make the cycles or levels more optimal. Okay, last slide. One theoretical concept, because in the databases, so maybe you noticed new technological trend in databases, it's a vector databases. And what is the difference to common databases is that the data storage in form of vector. So it means it's an array of numbers. So any data, text, audio, video data, it's an array of numbers. So internally it processed as a number. So it's for computer, it's the fastest way how to process data. So maybe this is a new technological trend in databases. It's a question. Of course, because in the past, several times, the mainstream is still relational databases. And in the past, several times happened that new database model comes object-oriented or some NoSQL databases. But still, relational databases are mainstream because producer of relational databases add new technology to their products. So for example, Oracle relational databases is possible to operate as an object-oriented database. So I suppose that the same will happen, and the producer of relational databases apply vector technology to their system. So it will be possible to combine relational approach with vector processing. So, okay, I think my time is fulfilled. So thank you for attention. If there are any questions, I am ready to answer. No question.
Thank you so much sir, for your time. Now I'd like to call Mr. Rishi sir on stage to present a token of reverence to our guest. Thank you so much sir, for your time. And now it's time for the third keynote talk of today, which is Dr. Kathleen Pine-Ruler, a multi-award winner, entrepreneurial executive with 24 years experience in SW engineering, 18 in ML and AI, and 21 years experience in developing autonomous electric specialized in both growing sales at startups and large-scale corporations. She has proven C-level partnership development and networking skills in building strategic collaborations with robotaxi providers, R&D facilities, and tech suppliers. Well-structured and highly motivated by the future of AI technologies, she is a multilingual, cross-cultural team builder with a can-do attitude and the ability to define and develop successful business strategies. She is passionate about building, leading, and mentoring highly motivated and efficient international cross-functional teams. Systems engineering, software engineering in PHP, Prolog, Java, C++, C, Python, HTML, JS, SQL, REST, JSON, enterprise and systems architecture, cybersecurity, AI, Gen AI, machine learning, big data management, non-SQL, RLDB, research in AI, quantum computing, sustainability in AI, and data science are her technical strengths. She's focused and entrepreneurial and thrives in the fast-paced dynamic environments with a specialty in grasping, analyzing, and resolving highly complex situations quickly and accurately, while cultivating collaboration and interpersonal relationships and creating win-win situations. We welcome you, ma'am.
Thank you very much for inviting me here. I'm very honored to be, and I'm also very thankful to you all, the audience. So a big applause to all of you because you're still here. So I usually like to do my lectures very interactively, precisely because I'm usually, and sometimes when this happens to me, the last presentation before lunch. And I know you're all hungry, and I won't keep you too hungry. So to make it interactive, what I want to talk to you about is about quantum computing. How many of you know what quantum computing is? Raise your hand. Okay. So, quantum computing is based on quantum entanglement. So the laws of quantum mechanics. Now raise your hands, whoever here knows what quantum entanglement means. All right, so because I'm in India and I've been learning quite a lot about your culture these past days, I'm going to explain this very simply. And because today is also the 14th of February, so Valentine's Day, I'm going to explain quantum entanglement the following way. Think it is a Bollywood love movie about the love triangle. And at the beginning of the movie, you have a girl with two boys, and you don't know which boy the girl is gonna get. And then some things start to happen, different situations in the movie, a lot of different states, and then there's a lot of dancing. See that? And then there's the final outcome and a big, big party. So quantum entanglement is very similar, and that is one of the main challenges in quantum computing. So what is the difference between a quantum computer and a regular computer? Well, the number one thing is the structure. A computer, you hold it in your hand right now, and you see it's all integrated, an IC, an integrated circuit. A quantum computer is actually, as you can see then, right here at the very far left. Number one, based on this physics in that they run in parallel, these two qubits, as they're called quantum bits. That means they execute an activity at the same time. But just by the same form of my example, it's very difficult to know what the outcome is going to be. Because at the very first measurement, whenever it's observed, it changes its state. So similar to the log triangle, we don't know at the very beginning exactly what's going to be the outcome. So it's very error prone. It's used for very fast computations, and the way that we do it is that at the very core level, is what you see is the hardware. It's cooled down using liquid hydrogen to 0 Kelvin. That's absolute zero, very cold to absolute zero. On the sides that you see in the top, that is cooled down to 100 microkelvin, and this is the power mechanism. Yeah, so on the top and on the sides, what you see are GPUs and TPUs that are used as an operative software system in order just simply to check what is going on. Is the output correct or not? And then there is the computers on the right side, which are where the fun starts, which is the one I'm going to talk about, which is what we call the quantum emulation. When we're really using that particular outcomes for any kind of use cases, be it AI, GenAI, blockchain, or machine learning. So quantum information, as I mentioned, is used for very high computation. I'm having trouble trying to.
Bravo.
computer hub, and the quantum computer hub has actually 4 computers, one of them from IBM, the other one from AWS, and 2 from the Technical University in Zurich. So for that particular system, we are accessing it using AWS, but just like what you would have with any standard application, you would have your data, you would have your particular user access layer, you would have what would be the data integration, and then you would have the layer with all the area for the particular business cases that we want to do. So what are the advantages versus conventional computing? So agility in architecture, design for scalability, security consideration, and improved database performance, which means that quantum computing is able then to create very complex mathematical algorithms. So it can use and be used for cryptography and life sciences, which are the main use cases that we're using right now in our research. So you can see here now a simplification. So from the source system, we're getting all the different data, and data has already been said by the previous presenters, is the basis for any good model in AI. But the point is, how do you know you have the right data? What do you think was the choice that that girl from that love boy would be making for the right boy? Is it fulfilling the particular requirements? And so just like sometimes girls might have a list of what's the perfect man, also for the particular use cases, there's a particular need for the right data for quantum computing. So we were accessing over the cloud in AWS, and then we were using what would be then Glacier in order then to first make the entire data scanning. And then we were using here also generative AI principles in order then to understand and talk to the data regarding if the data was qualitative or not. And then we're using quantum redshift. It's also based on Oracle database in order then to run the particular simulation of the use case that we were doing. And then in Amazon S3, processing the outputs out and creating the particular reports and data extract on SAS. This is a very simplified view. Some information is that the German government has invested 720 million to support right now the transition in quantum technology. In Switzerland, also we have over 500 million US dollars in research. So we have a cooperative project along different universities worldwide. But as you can see, the USA, China, as well as other countries are all investing in quantum computing. Why do you think it is, even though it is such a rare application? Number one, because you can do what I call AI for good. In the case of healthcare, for example, less than 2% of all medicines or medical care are made targeted at facilitating the healthcare of women or young girls. So yes, that means that when you're taking an ibuprofen when you have a headache, for example, and you're a female, that actually was made mainly thinking about male patients. So with using quantum computing and the ability to be able to process petabytes of data in days and not weeks and not months, we're able then to advance the research for better care, for personalized care. So how does a quantum algorithm at the software application level works? So there's different kind of structures that we use. In this case, I'm using a life sciences approach for treatment in regards to finding if a particular medicine is adequate for the genotype and healthcare history of a particular female patient or female patients, which is what we were researching. And we start here creating the mathematics and the algorithms based on a particular use case. For example, using quantum annealing to simulate the structure of the molecules to determine if the medicine is adequate. Then we're using a neural network in order to mimic the structure of the human brain, the structure of a particular person. Think a human digital twin. Then we use quantum cryptography because, of course, we want to ensure that this data is secure, that nobody wants to have their data exposed on the internet, for example. Then we use accessing, as I mentioned already, with the quantum cloud. And then we build the AI on this, what we call quantum cognition. Quantum cognition is where we have, imagine, a group of experts, think about several doctors, several scientists, that know the different treatment options, risk assessments, and lifestyle choices data. And when you go to the doctor, it asks you, well, do you smoke? Do you drink too much alcohol? Or you're healthy? Do you do exercises? Similar to how that medical doctor would make a decision to make a particular diagnostic or a particular health control. This AI does the same, but this AI is using petabytes of data by the millisecond. So that is here one of the changes. And then, of course, we have quantum machine learning that we're using it to identify the patterns. And just again, to use the example of the girl, there's several states happening along the movie that makes it decide and learns, this is the right partner, this might be the wrong partner. The same thing quantum machine learning uses to understand and predict patient outcomes, to be able then, and what is the benefit here? Much more accurate diagnostic, because it's using the precise genomic type and the precise history type of every single person. That means for the very first time, we will be having within 3 years personalized treatment, personalized clinical treatment and medicines for people. And a particular point in this particular research study that we're doing, also making it more cost effective. That means in certain countries, give it a fair price than what would be in the developed countries. This reduces considerably the research and development costs. So how does it look like? I'm sorry that I'm not presenting every single slide because I've been told I only have half the time that I planned. So number one, we need the database that you saw at the beginning. The different ones, we have the different collection of medical images, could be MRI scans, CT scans, X-rays, and then we start processing the data, and then start using the machine learning to identify the different features, textures, patterns, and then you've seen, or we've heard also from the previous presenter that it's right now a challenge because of race, because of the particular then different patterns of different skin colors. It's very difficult to identify if there was a cancerous particular skin piece or not. So through this, we're able then to use the algorithm and give it all the proportion, all the colors, and all the different n plus n combinations. And that way it is much able to detect tumors and cancerous tissues in images, because it has all these different type of data. And at the same time, we use also quantum image processing to interpret and reconstruct every output. That means we do have a human in the loop because of the error correction mechanism at the moment, to say, yes, this is actually what could be then a cancer for a person of color, or for a brown person, or for a white or yellow person, and these are not. So by doing that, through this validation and verification of the images, the algorithm learns within 1 day, and then starts generating synthetic data of the light in order then to become smarter. So from this, we're able then for the very first time to have a gathering of insights, a different identification of variables, and then start encoding this in the qubits. And one of the key benefits, because this is a school of business, so I'm bringing you here the two business cases that I created and I'm postulating it as a hypothesis with my team. But the research that we're doing, that we say this is the first time that we can use price optimization. So creating market dynamics, pay parity features and government regulations and bringing about broadcasting, like I said, to a fair price for the right particular geographical locations. And at the same time, we're able then to reduce the costs. Why? Because the effectiveness, not just during R&D, but also during production and the particular target groups, that means the supply chain manufacturing management would be benefited. Why? Because they would know for which data, for which particular patient that could be needed, that could be used. So if there is, for example, during the pandemic, it was very difficult to establish how much vaccine was needed, and how much vaccine was not needed, and also the particular factors of transportation and temperature and adequacy. And there has been, of course, then serious adverse effects, because there was not enough time to test. And this, in a very short time, considers a lot more, but not 10 of the thousands of different combinations to see if there will be an adverse effect. So there is here a particular then positive impact, because there's also then an optimized result, but also in the particular supply chain, hospitals would be able then to have the particular medical supplies when needed, and the same thing as the availability, and for which, let's say, particular groups it would be useful and for which not, and that way reducing waste. But then, of course, there are a lot of challenges still, and that's my motivation for all of you here today. There are still computer science or mathematics. We need you in the research collaboration space. Why? Because qubits are still very fragile, and if we're going to advance in quantum computing, this is a collaboration task in which we need physicists, we need chemical engineers, we need, of course, computer scientists, mathematicians. All of us are working together, even right now, in order to be able to reduce the size and the error complexity in quantum computers. Just to give you particular idea how big our computer is double the size of this room. That's how big our quantum computer is at the ETH Center in Zurich. And the very first computers were actually also very big, and now everybody has them in their pockets. Why? Because of people like you able to discover the mathematical, the mechanical, or electrical or electronical findings that were able to make that happen. And here's where we need you with your new novel ideas to help us solve these particular issues. Not just from the mechanics, but also from the particular hardware development and the software development. And here, I would like to tell you something. The current programming languages were not made for quantum computing. That is one of the biggest challenges we have. So maybe one of you might invent the right and correct programming coding language that would allow to bring us to a true quantum leap. Of course, the high cost, there's very, very few quantum computers in the world. Prove a lot of just the size, but then of course, the challenges with the high temperature, it's an issue. There could be, let's say, some skill resource shortage, and that's why I'm mentioning here, in order to motivate you to study any of these fields, and then also quantum computing or quantum mechanics. So who's working with us right now? So our partners are Cognizant, are IBM and Google. So we decided, and of course AWS over Rigetti. So we decided then to go with them because they have the biggest Q128 size. And then this was when we started this project 2 years ago. That was before Microsoft had a breakthrough with the microchip that is able to reduce by 50% the errors. So at that time, In 2023, when we started, was created with the superconducting circuits, having the framework with the biggest qubit size for reducing errors. So how exactly does it look like? And so just very, very simple. Look at the table here in the middle. We start programming to every single qubit a particular parameter. For example, for a particular person, a qubit 1, the oxygen level of a person, and we give it again binary values. And all of these they run in parallel. So normal or normal, heart rate high, heart rate normal or not, respiratory rate, normal or not, respiratory rate, high or low. And then the surface starts sinking, starts doing little bands, as I mentioned, to use the analogy again. And then a particular outcome comes out that we start to measure, which is one of the most challenging tasks, understanding and interpreting the outcome. But through this, we're able then to, like I said, have more accurate prescriptions and assist better in the understanding if a particular treatment was adequate for that person or not. So now let's look into the application layer. So the application layer, we created a generative AI application. Number one, a machine learning algorithm in which we started training it with all the different kind of protein structures and sequences. So we actually had 5 different types. The first was the genome of the particular patient. The second was the structure of the medical treatment. That means the particular bacteria or virus that was used in order then to create the vaccine or the treatment. Then the tertiary was an acting non-problematic third either microbe or virus. And then the fourth structure was a real attacker, was a real problematic structure. So we started then creating combinations of those 3 to see, can this particular vaccine really be able then to attack the real, let's say, problematic agent or not. So what we were starting doing was generating what we call novel protein-protein interactions, and then start giving it with different therapeutic functions, different states. That means different doses. It's not the same doses that you give, for example, for COVID vaccine to a child or to an adult. It's usually about half. Similar things we were doing here. And then we started bringing a lot of different experimental data into the LLMs, and all the rules that we were teaching it before. That means the knowledge from a medical doctor or a particular chemist or a particular pharmacist. We were giving all this information with this different kind of functions. And then we started then letting it act as if it was doing a digital twin simulation of a laboratory in vivo testing. So this is also actually a very good application for ethical purposes, because it prevents any kind of human harm. And currently the state pharma still is dependent from volunteers in which they want to, or they are getting paid in order to test something. So they're risking their lives. By having here a digital twin, that could be completely eliminated. So we created the Optimal Bio, which is the Cognizant AML platform for discovery and design manufacturing. So why are we using it for this pipeline? So it's got all these different scientific themes. Unfortunately, I don't have the time to go through all of them. We have then the different platforms that we showed you there before. And the most important part is our bioinformatics package. What is in there? So it has what we call this protein language model-based solution, also running a protein structure-based solution, which we call it cryo-INI. Why cryo IM? Because as I mentioned to you, quantum computers are running at absolute zero. So this is the very first time that we create an algorithm that is made to run in computers at absolute zero level. So it's called cryo emulation machine learning. And at the same time, this is able to be tested again, where we're using it with one of our customers. I'm unfortunately not allowed to say who, for vaccine discovery and for the discovery of these product and development processes. And why were we able then to do a test? So the pipeline, we have antigen discovery, antigenicity, and immunogenicity, and antigen design based on the characterization of the genes. What does it mean? It means that he might have a different history pattern, as well as different genetics. So he would have, imagine, a particular encoding, and so you can create a profile for him, the same thing then as for her. But they are all very different. Yeah, they have also different kind of diets, they have also different kind of lifestyles. So that also gets encoded into what we get, the cryo-MM, and that particularly protein structure. So there would be a Gemini A for this gentleman and a Gemini B for this lady here. And this would be coming into what would be the bioinformatics package and will be then executed by the scientific teams, getting results within 100 milliseconds. Still, the reason why it takes so long is because the thing that is stopping us to go faster and really be able then to mine it is the quality and the reliability, and of course, the data check layer. So I'm going to go into one slide to show you one example. I brought more, but for time reasons, I'm only going to show you one. So how does it actually work? So what we want to do here is to see, well, is the cellular adaptive immune response is relying the recognition of the T-cell receptors to develop the T-cell receptor specific protein language model, which in normal language is, if I give her the treatment, if I give him the treatment, would they have an adverse react? Or would it really work for them? So we started then grabbing our PCR model from before. So we started using Robert LM and the different kind of SME modules and our particularly cryo-EM machine learning algorithm in order then to make a prediction. And in the TCR is where we have all the different protein cell structures that we auto-generate. And from the very beginning, I mentioned to you before. Yeah, so the particular human cell, the particular microbe or virus, so the attacking agent and the non-problematic agent. So those are all into the TCR, and in the epilogue is where we started making the different vaccine treatment combinations. So from all of this, we'll be able then to make the analysis and bring about the outcome. Would this particular treatment be positive for her, maybe negative for him? So we created this protein language model. I'm going to go a bit faster this. So what we created here is then a research evidence portal, and an AI-assisted library for information, ontology, where we're always looking for partners that want to join our research in Europe. Because as I mentioned, this is still at a very early stage. Because we need the particular set, quantum mechanic scientists, mathematicians, computer scientists that would help bring us and understand if our research methodology and strategy is adequate. We started our one search strategy, and then we're using common and well tried and tested data and machine learning quality and responsible AI methodologies. The frameworks that we're using then today. But the hypothesis that we have is that they might be adequate as long as we are following the same software engineering methods, process, and tool principles that we have now. But as I mentioned before, that might be not the final solution. So we have a solution architecture right now that's configurable and scalable. Nevertheless, a lot of research is still needed in order to prove this to be and be used by the industry. And that's one of the very last messages here. This is a task that cannot be done alone. And that's why we're joining forces with Microsoft, AWS, IBM to continue this research. And last slide. And just like a love movie from Hollywood always ends in a happy end. Also, then there is this happy end for this conclusion. So what we were able then to do is accelerate the true R&D for a particular customer. That means facilitating their drug discovery, optimizing their drug discovery, predicting molecular interactions with unparalleled precision, eliminating the in vivo testing and its ethical repercussions, and creating for the first time not just personalized medicine, but predictive medicine. That means the benefit for her and him within 5 or 10 years, when this will go on the market after approvals. And then, of course, it's why we need for the research. With me, don't take that, do take that particular treatment. And I'm finished, and I thank you very much for your attention. Oh, sorry, yeah, you got questions? Yes. Yeah, what I was trying to say is that at the beginning is unpredictable, which is the main of the challenges within a quantum computer, yeah? How to measure it. Because if you look at the particular theory from Schrodinger's cat, I don't know if any of you have heard of it, but the principle that Schrodinger is mentioning there is that the moment that you look at the box, yeah, maybe the cat already moved, maybe not. And so along the observance point, we change the state of how the cat is, or maybe the cat is no longer there. So that is the first challenge. And that was my analogy with the movie. When you have a love triangle, you don't know which boy the girl is going to choose, A or B. And it's the same thing with a qubit. You don't know which state is going to be at the beginning, 0 or 1. And qubits are running in parallel. Maybe right now it's 0, maybe right now it's 1. You don't know. So that is the very first challenge that we have at the hardware level. How do we ensure that we measure the right state when we are knowing that it's the reliable value? So that's why it was my analogy of that. So that's why my analogy went further. So how do we know which boy the girl is going to choose? Because a lot of things happen in the story. Yeah, there's different states, as we call them in the quantum world. Yeah? So there is a particular, let's say, electricity state measurement, a secondary and a third and a tertiary, for example. We can do a lot more. Just like in the movie, yeah, one boy would give the girl flowers, the other boy will give her chocolates, one boy is nice to her, the other one yells at her. So you would know, oh, she's gonna go for the one that treats her always nice. So we go for the quantum state in which the electrical measurement is almost the same. Yeah, so which there is in the chart, unfortunately, I didn't have time to show that slide. You could see, yeah, that is following one and the same pattern. And that is the state that I'm going to trust. And so That was the, in our shows. Any more questions? I know you're hungry, so let's go for it.
Thank you so much, ma'am, for your words. I would now like to request Dr. Rishi Rajan Sahai to felicitate ma'am with a memento and shawl. I would request Dr. Kumar Vijay to please felicitate ma'am with a memento and shawl.
The next one is the Lifetime Achievement Award, which is awarded to Prasanna Lakshmi Balaji.
We again have Mr. Saurabh Agarwal for the Multidisciplinary Research Award.
And now, for the Best Researcher Award, I would like to invite Dr. Rishi Rajan Sahai to give the award to Mr. Shafi Ahmed Farah.
Next up is Research Achievement Award, which goes to Dr. Sudhanshu Gonge.
Next up is the Teaching Excellence Award, which goes to again Dr. Sudhanshu Gonge.
Up next, we have the Research Achievement Award, which goes to Dr. Shashank Degadwala.
And now we have the Best Paper Award, which goes to Akshata PS.
Next up, we have the Multidisciplinary International Research Award, which goes to Dr. Biswajit Brahma.
And now, the last but not the least, the Best PhD Thesis Award goes to Dr. Sandeepan Dhar. Congratulations to all the awardees today. We congratulate all the winners for their dedicated efforts in their respective fields. It's now time to proceed towards the lunch break. The sessions will resume after 40 minutes in these following rooms.
I request the participants, those who are having the presentation today, were requested to be there in the meeting, and those who are having the presentation tomorrow, kindly leave the meeting. We will be opening the breakout room, and after that, the sessions will start. I request those having the presentation tomorrow, they can leave now, and those having the presentation today, kindly be here in the meeting. Within 2 to 3 minutes, we are opening the breakout rooms. After that, every particular author who is having the presentation can able to go into their respective session. Before this, I request every author kindly rename their profile name as the session number hyphen.
Sir, can we leave from here?
Yes, if you are.
Oh, excuse me, sir. Can I leave from here?
Yes.
Okay, okay, sir. Okay.
We will be creating the breakout room in another week. Request.
Sir, your voice is not clear.
Sir, what about today's attendance? Hello? Hello? Hello?
Yes.
Sir, what about today's attendance? It's not audible, sir. Can you type it in chat box?
Hello.
Your voice is breaking, sir. Please type in the chat box.
Your network connections. Fine. Because we have to start sessions. It would be those who are having the presentation kindly request the participants to find paper ID.
Sir, please, your voice is not proper. Can you please repeat? You are
I
not
request-
properly
Cannot
audible.
hear you. Actually, we cannot hear you. The voice is breaking.
Yes, sir. Even we are facing the same.
Yes, sir. We are also facing the same issue.
Now audible? Hello.
Yes, sir.
Yes,
Yes, sir.
Yes, sir. Yes, sir.
I request the participants, those having the presentation today, kindly be here in the meeting. We are opening the breakout room shortly. Those who are having the presentation tomorrow were requested to leave the meeting. Okay.
Okay, but sir,
All
one
the
thing,
keynotes, all the inaugurals were done. Now we will be starting the sessions. We will be opening the breakout room another 1 minute. So I
Okay.
request the participant, those having the presentation tomorrow, kindly leave.
yeah, one thing, sir, today's attendance has been recorded or what, sir? How it
Now
is?
I request the participants to rename their profile name as the session number hyphen their paper ID. We are opening the breakout room. You can able to see the breakout room option on your screen.
Yeah,
At the
but
below where the Zoom meeting is, at the below there is the option of breakout room. In that in the breakout room option, there will be 5 rooms open. You can go to the respective room. We are opening it. Kindly open.
sir, regarding the attendance, sir, I'm asking.
Yeah, it's taken. It's taken.
Fine, sir. Fine. Can you please confirm my attendance, sir?
We will
Yes,
confirm you because right now we have to start our sessions. Parallelly, the session will start.
fine, no problem, sir. Thank
So,
you.
thank you. So the breakout room are open. The session chairs, we will move the respective session chairs to their respective room if they could not able to move themselves. But I request the authors, you can able to see the pop-up menu of the breakout room. You can go to the respective room of your particular session.
Hello, sir. Hello.
Hello, yes.
Yeah, sir. I just wanted to know tomorrow is my presentation. Just wanted to know what's the timing of my presentation. I'm in
You
session
need to
8.
you need to connect at around 10:45 sharply.
Okay, sir. My ID is 783.
Don't not worry.
Okay, sir. Okay, 10:30. Thank you, sir.
Hello. Hello.
Yes, hello. Yes.
Good afternoon, sir. Sir,
Good afternoon.
actually, I was not able to find my session number
What is the paper ID?
741.
741. Just a minute. It's in session 5. Okay.
Okay, thank you.
I request the authors to kindly rename their profile name as the session number hyphen their paper ID. We will be moving the session chairs at last. So do not worry. In another 5 to 10 minutes, all the session will start. So do not worry. Those who are in the main room, please be here. Our technical team is doing the work. They are moving the respective authors and the session chairs to their respective rooms. Before this, I request only the authors, those who are having the presentation tomorrow, you can leave because I can see the authors of S10 ID, S11 session, S10 session. Today, we are having the session from 1 to 5 only. On tomorrow, we will be having the session from S6 to S25. So I request the authors to kindly leave.
Excuse me, sir.
Yes, yes.
I am Sudhir Kumar Gupta.
Yes, yes, sir.
Bas-
Yes, sir. Yes, sir.
Basically, I was requested for online session. My
We
session
will
was
move to you,
earlier
sir.
assigned
Yes, yes, yes.
offline.
Do not worry. Do not worry. Do not worry, sir.
I'm waiting for today. Okay,
We
sir.
will
Thank
move
you.
to you in session 4. Okay.
Okay. Okay. Thank you.
आप move कराओ. बच्चे आ रहे हो ना? दीपांशी हैंडल कर लीजिए. आप यहाँ से. I request the paper ID 983, the paper ID 1067, the paper ID 1077. I think the presentation is tomorrow. Kindly leave. Session 12, session 13, session 14, session 15. I request each and every, because I could not able to remove them. It's not, it will take much time. So I request the authors to kindly leave the meeting because it's really creating a confusion for us. Okay. So for today's inaugural and keynotes were finished. Right now, parallelly, the session is going to start. S4, S5, S1, S2, 3, 4 को बताया वो अभी सेशन चेयर्स को मूव करो दीपक शर्मा सर को मूव करो नॉट ब्रांड सेशन 5 where will be the presentation for 7 session सेशन 7 सेशन 7 का आज तो नहीं है सर सेशन 7 का तो कल है ऑफलाइन अच्छा आपने ऑफलाइन कराया क्या पेपर आईडी है 711 ये तो आपको मुझे रेस्पेक्टिव रूम बोलना पड़ेगा ऑफलाइन है ना सेशन से सॉरी सेशन एक्चुअली सेशन 5 तक ऑनलाइन है तो कंफ्यूजन वो हो रही थी सेशन 7 का 7:40 अभी लंच कीजिए सर 7th floor
Sir, excuse me, sir.
yes
Sir, paper ID is 159 and sessions 2. The presentation is today or tomorrow?
paper ID is
159.
159 it's in session 2 okay we are moving to your respective session करा दिया उसे पता नहीं चला होगा कि बेसिकली
Sir, at which time we have to start the presentation?
I think many of the participants are right now in the room. Please, today everything is finished. Right now, parallelly, 5 rooms are open and the participants were giving their presentation. Those having the presentation tomorrow, kindly connect at around 10:45. Okay.
Excuse me, sir. Hello.
You can leave now. The paper
Sir.
ID who have having their session in S10, S11, S12, S13, they can leave now. S14, S15. From the session 6 to session 25, they can leave now.
Excuse me, sir. Hello.
रुक जाओ अभी. I request the participant to kindly leave. If you are here, your presentation will not be today. Your presentation will going to be on tomorrow only. So I request the participant to kindly leave the meeting. Otherwise, we have to remove you. Yeah, S2 159. You are in the main room. Your voice is not audible.
Sir, where I am joining?
Session 2, na?
Yes, sir. Please shift me
Yeah, yeah.
there.
We are shifting you.
Paper ID number 229. Your presentation is small.
Hello, dear professor. Please transfer me to session 24. Session 24.
Your session is scheduled for the tomorrow.
Tomorrow?
Yes.
Okay, in the same time, isn't it?
Timing is 2:14 IST Indian time.
Tomorrow? Okay, professor.
Tomorrow 11:15 IST.
Okay. 11:50?
11:15 IST AM.
AM. Okay. 11. Okay. Thank you very much.
Excuse me, sir. Excuse me. Hello. Am I audible?
Yes.
Hello. Anji. Hello,
Yes.
sir. Can I put my query here?
Yes, you can put your query in the
From
chat.
last half an hour, I left the meeting just because phone was switched off, and now I charged my phone and again joined the meeting. Kindly tell me my time for the paper presentation for tomorrow, because tomorrow is scheduled session 25 and paper ID is 916.
Uh, 11:15 AM IST tomorrow.
From 11 a.m. Meeting will be started.
Yes.
Okay. Then one by one session will be going on, na? So session 25, maybe while attending the meeting, I will get the right and correct time, right?
Yes. 11 o'clock the meeting will start.
Okay. Okay, sir. Thank you. Sir, is there any important information if I missed something? Because from last half an hour,
No,
phone
ma'am,
was switched off.
no, ma'am, there is no important information that have been I scheduled.
Okay, my paper is scheduled for tomorrow. Presentation is scheduled for
Yes,
tomorrow.
yes.
Okay. Okay, sir. Thank you, sir. So shall we leave the meeting now?
Yes, you can leave the meeting.
Okay, thank you, sir.
Hello.
Hello.
Sir, good afternoon, sir. Sir, good afternoon.
Hello.
Sir, when the other session will start, sir? Next session.
They got a reply. Wait.
Hello. Excuse me. Hello. Hello.
Sir, excuse me.
Excuse me.
Sir, 21, Dr. D. Bujubabu.
Excuse me.
Sir, excuse me, sir.
Can you move me in
Hello.
can you move me in room number 4? Slot number 4.
Flat number.
Yes. Session 4. Actually, I don't have the link to directly join the session 4. Hello.
Hello, sir. Hello.
हाँ जी.
Hello.
हाँ जी.
Sir.
आवाज आ
Sir.
रही क्या?
Hello, sir. Just a minute.
Hello, sir.
Yeah, yes, please move me in session 4.
Session 5, 421.
720.
421.
421.
Sorry, I was in that session, but due to internet connection, I was out and I do not have direct link to go there. So can you move me in session 4?
Hello.
Yes, please.
Hello.
Sir, change your name from session 26 to session 2.
Okay.
Session.
Sir, myself, Dr. Bujubabu. I am the author of 421 paper of session 5.
Hello.
Hello.
Yes, sir. I'm saying that change your name from S26 to S2, session 2.
And for me?
720. Wait a second.
Time.
Yes, 720.
421.
Can you please move me to session 4? Excuse me.
Hello.
Yeah, please move me to session 4.
Okay, so 1 second.
Hello, dear Professor. Professor, please, session 24 tomorrow and anytime.
Respected sir, your session is scheduled for tomorrow.
Tomorrow and anytime, please.
Sir, tomorrow timing is 11 o'clock a.m. IST.
11 o'clock a.m.
Yes, 11 o'clock a.m.
11 o'clock a.m. In Mumbai time, isn't it? In Mumbai time?
Yes, yes,
Okay.
yes.
Okay, thank you very much. Thank you very much.
Hello? Hello? Is there anybody? Hello, Tane.
आपको अनजाने नंबरों से सिम बंद होने, बिजली कटने।
हेलो, क्या कर रही हो?
सर वो कामिनी मैम वाले में
नाम भेजा
You all can leave the meeting.